Hey everyone, welcome back to the channel. In this video, I'm going to answer questions I often receive on my how to build a do-it-yourself glycol system that include how I built my heat exchanger, how I modified the AC unit, and what's the largest size fermenter that this system supports. Make sure to check out this video if you want to learn how a do-it-yourself glycol system works in more detail. I'll also show you how I replaced my AC unit for improved performance, swapped out a pump that recently stopped working, refreshed my glycol reservoir, and test how long it takes to cold crash 10 gallons of 70-degree water. There's a lot to cover, so let's get started. Hit that subscribe button if you want to be notified on homebrewing content like this in the future. This system has really worked well over the past few years. It's been able to maintain precise temperatures of all the beers I brewed, including lagers, and I've been able to cold crash beers right in my garage. Here's a rundown of the major components I used in this system. Starting at the top of the system, I used two 7.5-gallon bucket fermenters. Each fermenter's lid was modified to fit a heat exchanger called a twister. I'll post links in the description for all the parts and tools I used in this video. This heat exchanger extends the entire length of my fermenter, and it's extremely efficient in maintaining fermentation temperatures. Installation was pretty simple. I drilled 2 holes on the top of the lid with a step drill and shaped the stainless steel lines to fit through the holes. This heat exchanger came with 2 duo-type fittings that securely locks the stainless tube in place. I cut off excess tube with a pipe cutter and added 90-degree duo-type fittings to direct the tubing downward to prevent the line from crimping. The tubing from the heat exchanger connects to SS Brewtech Quick Connects. They have built-in shutoff valves that prevent glycol from spilling while disconnected. This allows me to disconnect the lid from the system for cleaning. The tubing is covered in a neoprene material that keeps the lines organized and protects the vinyl feed and return lines. The other half of the glycol lines are attached at the top of my cooler with couplers that secure the lines to the lid. I drilled 4 holes and screwed the couplers together with a nut on the back of the lid. I use a 16-quart cooler for my glycol reservoir, and it also holds the evaporator coil, which is the cold side of the AC unit, pumps that pump the glycol through the heat exchanger, and a temperature sensor that monitors the glycol temperatures. The AC and cooler assembly sits on top of a tray that can be removed for maintenance. The system is controlled by a DIY control panel that is mounted on the front of the glycol cart. It controls the AC, pump, and heating elements for maintaining temperatures. More information on how this control panel was built can be found in my How to Build a Control Panel video. Before any updates, I ran the system to see how it currently performs. At 42 minutes, I was able to cool the temperature of both fermenters by 18 degrees. However, the AC unit struggled to drop glycol temperatures to freezing temperatures. Recently, this system has been shown its age in regards to performance. The AC can drop the glycol to freezing temperatures, but it takes a while, and it struggles when the fermenters pump hot glycol back into the cooler. During this test, one of my pumps died, and from the color of the glycol, it was time to refresh my reservoir. From what I understand, it's a good idea to replace glycol every year or two, or when it turns a reddish color. First, I'll start with the AC unit upgrade. I'm using a backup AC unit I grabbed last year for around $30. Swapping out the AC unit was pretty simple. I disconnected the glycol tubes and wires and placed the system on my work table. This gives you a view of what the system looks like after an extended period of use. The glycol was discolored, and there was a little corrosion on the coil brackets. I originally placed the evaporator coil that cools the glycol in the cooler by lightly bending the lines and sealed it with foam. This method looks a little messy, but it worked really well. I carefully cut away the foam and lifted the unit out. Like any DIY project, make modifications like this at your own risk. Make sure you do your research before you modify any AC unit. The new AC unit has a slightly smaller footprint than my older one. I prepped the unit by removing all the unnecessary parts. I removed the front faceplate, the side extensions that expand across the window opening, and the fan attachment that pushes air over the cooling coil. I removed the fan and all the surrounding styrofoam around the fan. And just like my first AC unit, I carefully bent the evaporator coil lines so I can place it inside the cooler. This doesn't require much force. I gently moved it forward, enough so I can insert the tubing in the cooler. With all the unnecessary parts removed, and the slight modification to the evaporation coil, I positioned the AC next to the cooler and carefully slid the cooling coil through a cutout on the side of my cooler. And just like my first build, I grabbed a bottle of spray foam and sealed the gap on the side of the cooler to keep the glycol in the cooler. I made one more modification to the AC unit to ensure the AC remains on while cooling the glycol by bypassing the thermostat controller. I bypassed the thermostat by opening the control box, located the thermostat wires going to the thermostat controller, cut and tied them together with a wire nut. This will ensure the AC will stay on until the set glycol temperatures are reached. Next, I added my 2 glycol pumps. I picked up a replacement pump for the one that recently died. If you've seen other videos of mine, you'll know I'm a fan of the Anvil products. But I decided to try a less expensive pump that had similar flow ratings and was a direct fit to my glycol lines and power adapter. So far, I'm happy and the pump is working as expected. Next, I filled my cooler with a mixture of propylene glycol. I use 1 part glycol to 3 parts of distilled water to ensure I can operate the system at 26 degrees. My reservoir comfortably fits 2 gallons of the glycol water mixture. After the glycol was added, I placed the system back in my cart, made sure all the pump, return lines, and wires were neatly tucked away, attached the glycol lines, and the system was ready for a test run. I get quite a few questions on how this system maintains temperatures, how well it cold crashes, and what's the largest size fermenter that this system can handle. Based on my previous results, this system can handle 2 5-gallon fermenters without a problem. For larger batches, I would increase the size of my glycol reservoir and upgrade my 5500 watt AC unit to a larger system. And now for the test run. I heated up 10 gallons of water to 70 degrees to simulate fermentation temperatures, and then poured 5 gallons into each fermenter, closed the fermenters, and inserted a temperature sensor into each fermenter in order for the control panel to sense when to turn on the pump. I'm going to see how long it takes both fermenters to get down to 40 degrees, right around cold crashing temperatures. Before I started cold crashing the fermenters, I turned on the glycol chiller to bring the glycol down to 28 degrees. At right around 3 minutes and 40 seconds, the system hit its operating temperature. Even though my previous AC could hit 28 degrees, the new AC brought down the temperatures much quicker. Now on to cold crashing. With both fermenters filled with 5 gallons, I turned on the pumps to start recirculating the glycol through the heat exchanger. The first fermenter started at 72.1 degrees, and the second fermenter started at 68.1 degrees Fahrenheit. It took a little over 3 hours for both fermenters to reach 40 degrees. I typically spread cold crashing over a day or two, so based on this information, this system could definitely handle cold crashing 10 gallons of beer. Let's take a closer look at the data and compare how the 2 fermenters performed during the cold crash. The first fermenter dropped from 72.1 degrees to 54.1 degrees during the first hour, 46.1 degrees the second hour, 41.8 degrees the third hour, and hit 40 degrees the final 15 minutes. The second fermenter dropped from 68.1 degrees to 53.2 degrees the first hour, 45.6 degrees the second hour, 41.1 degrees the third hour, and 37.9 degrees the final 15 minutes. On average, both fermenters lost 16.5 degrees the first hour,
7.8 degrees the second hour, 4.4 degrees the third hour, and 2.5 degrees to finish off the cold crash test. Both fermenters perform almost the same during the cold crash. The second fermenter hit 40 degrees a little sooner, but also started off a few degrees colder. The first fermenter took an additional 6 minutes to hit 40 degrees.
All in all, this was a successful test, and I can't wait to use it in my next brew day. If you have a glycol system, I would love to hear how it performs in a test like this down in the chat. Thanks for watching. See you next time. Cheers.